Hello everyone. So here we look at a few examples of mechanical vibrations, and the way the question is worded in your homework, you could see the directions, and we want to find the position function for the motion, and if it's underdamped, we're going to write it in this special form, and then they also want us to find the undamped position function, no matter what the situation is. And that would be by letting the dashpot be equal to 0. Okay, so then they want us to construct some graphs, but that's really not all that much of a concern. But the way we start is with our standard equation that mx double prime plus cx prime plus kx is equal to 0. And so it's just a matter of substituting the given values, and they are constants. So we have 3x double prime plus 30x prime plus 63x is equal to 0. And just to make things easier, we could divide everything by 3. So note that this is just simply a second order linear differential equation. It's homogeneous with constant coefficients. And so we'll just divide everything by 3 since that's a common factor. And we have x double prime plus 10x prime plus 21x is equal to 0. Remember, x is a function of t. That's what we're looking for, x of t. And so, as normal, we'll just get the characteristic equation, and that would be r squared plus 10r plus 21 is 0. And if we factor that, that actually does factor, is r plus 3 and r plus 7. So we set each factor to 0, r plus 3 is 0, and r plus 7 is 0. So we get two real distinct roots. R is negative 3, and r is negative 7. And so that actually corresponds to the overdamped situation, where our general solution, x of t, is going to be able to form c1 e to the negative 3t plus c2 e to the negative 7t. And then we'll just use the initial conditions to find the constants. And so the first initial condition is that, well, the way they stated in the homework, x of 0 equals 2, which means that x of 0 is 2. So that's saying that 2 is equal to, so x is 2 when t is 0. So 2 is c1 plus c2. Alright, there's one equation with two unknowns. The second initial condition states that v sub 0 is also 2, but note that v sub 0 is really x prime of 0. So I guess I should have actually, at this point, found x prime of 0, x prime of t, that is. Let me just do it right here. X prime of t would be negative 3c1 e to the negative 3t minus 7c2 e to the negative 7t. So then, using the fact that x prime of 2 is 0, or x prime of 0 is 2, I'm sorry. gives us that 2 is negative 3c1 minus 7c2. And so now we need to solve that system. And so to solve that system, I'll just line up the two equations. 2 equals c1 plus c2, and 2 equals negative 3c1 minus 7c2. And what I'm going to do is just multiply the top equation by 3. Then that'll make the coefficients of c1 equal but opposite. So we'll have 6 equals 3c1 plus 3c2, and 2 equals negative 3c1 minus 7c2. So adding the two equations, we get 8 equals, c1's go away, negative 4c2. So then c2 is negative 2. And then we'll back substitute to get c1. And easiest equation to go to, I think, is this first one. 2 equals c1 plus c2. And so 2 equals c1 plus a negative c2, negative 2 that is. So just minus 2, and c1 is 4. Okay, so then our solution is that x of t is c1. So we're going back up here to x of t, plugging in c1 and c2. c1 was 4, so 4e to the negative 3t, and then plus c2, which is minus 2, so minus 2e to the negative 7t. Okay, so that's with the damping, and then they wanted us to do it without the damping and write the simple harmonic motion equation. So that's what this is. This is here. This is just where they say call it u of t. That's just simple harmonic motion, because there is no damping, so it's just going to be a cosine graph. So just for the sake of doing it, we'll say without damping, c equals 0. Remember our equation, our general equation is mx double prime plus cx prime plus kx equals 0. In this problem, they had told us that m was 3, c was 30, and k was 63. And they also mentioned the initial conditions again. We'll repeat them here. X sub 0 was 2, and v sub 0, which is really x prime of 0, is also 2. But substituting a 0 in for c, instead of using 30, we get 3 x double prime plus 63 x is equal to 0. And again, just to make things a little bit easier, we'll divide out the 3. Actually, what we should formally do here, instead of calling it x double prime, this equation, we're going to, at the end, I'm going to leave it as x double prime, but at the end, let me just note this. We're going to change x of t to u of t at the end. Okay, so just note that. That's just kind of, because of the way they worded the homework, I just think it's going to be awkward to carry a u of t through. And so let's go with the x of t. So x double prime plus 21x is 0. Okay, the characteristic equation then would be r squared plus 21 is equal to 0. Okay, so there's a quadratic with no linear term. So the easiest ways to solve that is to isolate the r squared. So r squared is negative 21. Take the square root of both sides. So r is plus or minus square root of negative 21. And so therefore r is plus or minus square root of 21 times I. And if you want, you could write it as 0 plus or minus square root of 21I. So you know that it's coming from the r complex conjugate roots. And now we use our theorem for complex conjugate roots. And so we'll say x of t is e to the ax, so e to the, well, actually t, right? E to the 0t, and then times c1 cosine of b, which is the square root of 21t, plus c2 sine of the square root of 21t. Now, this is the one thing about the textbook questions that sometimes is a little tedious, because square root of 21 obviously is not the prettiest thing to work with. But before we consider that, consider the fact that e to the 0 is 1, so we just get c1 cosine of square root of 21t plus c2 sine of the square root of 21t. And I didn't do this in the first one, but it's advantageous at this point to calculate the first derivative, because we're going to want to use the initial conditions, and that involves the first derivative of velocity, because remember, velocity x prime of 0 sub 0 is the same as v sub 0, which in this case is 2. So we'll calculate the first derivative. So that'll be derivative cosine of this square root of negative 21t is going to be minus sine, but then times the derivative of the argument, which is the square root of 21. So I'm going to write minus c1 square root of 21 sine of the square root of 21t, and then plus, similarly, we'll have square root of 21 c2 cosine of the square root of 21t. Alright, so now the initial conditions. Okay, x of 0 equaling 2 really means that x of 0 is 2. And you don't need to write that. You could just jump right to the substitution. So 2 is equal to c1, and that's it. Because when we make our substitutions into x of t, remember the cosine of, when t is 0, remember the cosine of 0 is 1, and the sine of 0 is 0. So immediately we get c1, and then v of 0 equals 2 means x prime of 0 is 2. So 2 is equal to, and then we're going to get this first term goes to 0 because sine of 0 is 0. So we're just going to get the square root of 21c2. So therefore c2 is 2 over the square root of 21. Alright, so now our particular solution is x of t. Okay, we're going back to the simplified form here. C1, which was 2, cosine square root of 21t, and then plus C2, which is 2 over square root of 21 times the sine of square root of 21t. Alright, so now we have to transform that to be in the form of x of t equaling c sub 0 cosine of omega sub t, omega sub 0 times t minus alpha. And so to obtain that form, recall that we first need to consider a triangle. Well, consider a graph. Where the horizontal axis is labeled as A and the vertical axis is labeled as B. And remember, this is taking the form of A cosine omega sub 0 t plus B sine of omega sub 0 t. So therefore A is 2. Now this doesn't have to be to scale, but A is 2. Let's say that brings me here. And B is positive as well. It's 2 over the square root of 21. Again, it doesn't have to be to scale or anything, but let's just say that's up here. Alright, that would make a right triangle here. And this would be the value of C, because this is the value of B equaling, again, 2 over the square root of 21. So the things we're going to need, recall, were that C squared is A squared plus B squared. So C squared would be A, which is 2, has to be squared, plus B, which is 2 over the square root of 21, which has to be squared. So then we get that C squared is equal to 4 plus squaring the 2, we get 4. Squaring the square root of 21, we get 21. And then a common denominator of 21 gives us 4 would be 84 plus 4, so 88 over 21. So then C is, remember C is always positive. It's going to be the square root of 88 over the square root of 21. But then we could factor out the square root of 4, which is 2, and we'll be left with 2 square root of 22 over the square root of 21. So this is just going to get a little bit tedious because of these awkward radical numbers. And hopefully in the future, the way I design the problems usually, in the textbook you'll just have to endure this. The way I design the problems, they usually work out pretty. But in any event, we also want the sine of alpha. So this is our angle alpha. And we want the sine of that angle and the cosine of that angle. Sine is adjacent, 2 over hypotenuse. We just found it, 2 square roots of 22 over the square root of 21. So any 2's cancel, then inverting and multiplying, square root of 21 over square root of 22. Cosine of alpha, adjacent. Oh, actually I did that. That's the cosine, I'm sorry. So instead of having to change it around, that's the cosine adjacent over hypotenuse. And now the sine is opposite, 2 over the square root of 21 over hypotenuse 2 square root of 22 over square root of 21. And then we just get 1 over the square root of 22. Okay, and I'd like to find alpha as well. And because we're in quadrant 1, alpha is just going to be the inverse tangent of b over a. So you don't have to worry about, in this case, subtracting the angle or adding the angle to anything, because you're in a different quadrant. Since we're in quadrant 1, it's just the inverse tangent of b over a. So that's the inverse tangent of b was again 2 over the square root of 21 over a, which is 2. So that's the inverse tangent of 1 over the square root of 21. And that's 12.31 degrees. But then remember, we want to change this to radians. So multiply by pi over 180. And we get 0.2149. And that's going to be radians. Okay, so now we're ready to go. So we're going to rewrite. The function x of t was 2 cosine square root of 21t plus 2 over the square root of 21 times the sine of the square root of 21t. And recall what we do is we factor out c, the hypotenuse. And the hypotenuse we had calculated to be over here, 2 square roots of 22 over the square root of 21. And to get 2 from this, we'd have to be able to cancel out the square root of 21 and the square root of 22 that's in the numerator, square root of 21 that's in the denominator. So I'd have to have the square root of 21 over the square root of 22, and then that product would give me the 2 that's in front of the cosine of the square root of 21t. And then to get 2 over the square root of 21, I'd have to cancel the square root of 22 that's in the numerator, and then that would leave me with the coefficient of the sine here. And I could do that by multiplying by 1 over the square root of 22. And then the sine of the square root of 21t. But it's always going to work out such that the value of c that we factored can stay, but the new coefficient of the cosine is always going to turn out to be the cosine of alpha. So note that here. And also note that the new coefficient of sine, 1 over the square root of 22, is the sine of alpha. So therefore we could write this as cosine alpha, cosine square root of 21 times t plus the sine of alpha times the sine of the square root of 21 times t. And then by our special identity, what we have in parentheses is now the cosine of the difference. Cosine p cosine q plus sine p sine q is cosine of p minus q. So therefore we get cosine of alpha minus square root of 21t. But then by the other identity, that the cosine of a negative angle is the cosine of the angle. Recall that allows us to reverse the order. So we could write the square root of 21t minus alpha. And then finally, we could replace alpha. So we get the desired form. And alpha again has to be in terms of radians. And that was what we calculated up here. So the 0.2149. Okay, so I think I'm going to actually do the next example, which is the final example, in a separate video. So we'll stop this video and we'll look at the next example in a separate video.